Okay, finance students, welcome back. We are working on practice problem 6-2, and we're going to look at present value of an annuity, as well as calculating the payment, the annuity payment, and then also the number of periods. In ICA 61, you calculated the present value of annuities, the future value of annuities, and then also the rate. So we're going to look at present value, we're going to look at number of periods, and we're going to look at payment calculation. So we're going to start with the second one, third one, fourth one. We'll do that. Let you do the first one as you go back. So we look at this one. What is the present value of $1,000 at the end of each of the next 3 years if the discount rate is 8%? So for this one, we're looking for present value. Present value cell is highlighted. We can plug in what we know. Interest rate is 8%. Number of periods is 3. Our payment is $1,000. Going to be a negative, comes out of our pocket. So we know the future value doesn't tell us anything, so we're going to assume 0. So in order to calculate this, we run our PV function with our parentheses. Our rate we know is right here in this box, D17. We hit comma. We know our number of periods is 3. We know our payment is 1,000. You can include the future value. You don't have to if it's 0. Close parentheses. So we see that we would have a present value of about $2,577.10. So that is what those 3 equal payments of $1,000, if we discounted those back to today, that is what they would be worth. So remember, if you're working backward on a timeline, you call it discounting. If you work forward on the timeline, it's called compounding. Let's look at the second one here. Loretta Link has just retired and has $1 million invested for retirement. She's expected to live 30 more years, and would like to know how much she can take out each year at the end of the year to live on. If she can earn 8% on her investments, how much will she be able to take out each year? Sorry, this box is not completely big. So that she takes out the 30th year's amount, the balance in the account is 0. So that tells us right there we want our future value at the end of year 30 to be 0, to have nothing. And so we know we have 30 years. We know my interest rate is 8%, and she's going to start with $1 million. Okay, so that would be $1 million in the bank that she would have. So the question is, how much can she take out each year? So what would be the recurring equal annuity payment to herself so that she will drain the whole $1 million account at the end of 30 years? So the function that we would use, just like we did in Chapter 5, is a payment function, PMT. So what would be the payment that we would want? Well, we'd have a rate of 8%, not 80, 8%. Number of periods would be 30. Our present value is $1 million. Future value is 0. We don't have to include that. We're going to talk about type in a minute. Hit enter. That tells us that she could withdraw about $88,827 every year if she had $1 million in the bank, making an 8% return. Not bad at all. Last one we'll look at, if you invest $3,000 a year, how many years will it take to accumulate $1 million? The average annual return is about 10%. Okay, so the question is, we're looking for the number of compounding periods. How long would it take, or how many years? So we're looking for NPER, so that's highlighted there. We have. Let's plug in what we know. Okay, so if you invest $3,000 a year, how much will it take to accumulate $1 million? So we are assuming we're starting with nothing. We have a 10% interest rate. Our payment is going to be $3,000 every year. Future value would be $1 million. We want to have $1 million in the bank, so we can be like Loretta and take out $88,000 every year for 30 years. All right, so we have that information plugged in. The function that we would use is NPR. Very good. Number of periods. We're going to plug in rate. 10%. My payment is hidden back here, but we know that's a payment of $3,000. My present value is 0. You can plug it in or you can leave it blank. Future value is $1 million. Close that out. So this tells us it will be about 37.10 years. So it takes about 37 years to accumulate $1 million in the bank if we do it that way. Good reminder again, make sure you're saving for retirement early.